Okay, so in this question, x is going to 49. The limit is x goes to 49 of this fraction. You could start by just trying to put in the 49 for the x, because x is going to 49, but it won't work. You'll just get 0 over 0, which is unclear. So that means we have to try something else. So what are we going to do instead? Well, one thing to notice is you see how that 77 and the 11, do you see how 11 goes into both those? They have those in common. Whenever you see um, two things, two terms added or subtracted that have a number in common, like 11 goes into both of them, you want to factor that out like that. See that? 11 times 7 goes back 77. 11 times root x goes back to 11 root x. So, that'll help. That'll make this problem a little bit easier. Let me show you. Oops. So this will become the limit. In fact, let me move it. There we go. The limit as x goes to 49 of, and now we have 49 minus x, 11, 7 minus root x. Well, basically that 11, I'm going to take that 11 and I'm going to put it out in the front. I just kind of put it out there. Just kind of move it right out there. Because why? Because it doesn't have an X, right? It's just a number. So it doesn't matter if it's in front of the limit because the limit is stuff we're going to plug X into. So yeah, you might think, can you take this move? No, you can't move anything with an X to the front because they have to have eventually they have to have the 49 plugged in for X. But the 1/11th, the 11 on the bottom, yeah, that's the other thing. You might wonder, why did you just put 11? Well, because the 11's on the bottom. So you got to put 1/11th, right? That 11 went to the front as a denominator 11. So do that. That'll just make things simpler. Now, when you have a square root adding or subtracting another number or letter or whatever, you want to multiply the top and the bottom. I'm looking at this right here. Top and the bottom by, let's just say, let's A, by what's called the conjugate. And what we use this a lot in math. If you have x plus a, then you want to use, sorry, yeah, the square root. Yeah, I'm not being very clear at all here. Um, you have the square root plus a, then you want to use, yeah, just keep changing my mind. By conjugate, which means opposite. I'll just write it in words. Opposite sign in the middle. That's the conjugate. So I'm going to multiply by 7 plus root x, top and bottom. Does that make sense? Because I had a root and added or subtracted to a number, I'm going to multiply top and bottom. You always got to do the same thing, top and bottom, so you don't change the value of the fraction. You can't do like plus up here and minus down here or something like that. That'd be illegal, right? You'd change the whole problem. You can't change the value of the fraction just the way it looks. And to make sure you're not changing the value, you make sure you do the same thing to the top and the bottom. And how do I know I want to do this? Well, whenever you have a root with an adding, subtracting, you want to do the conjugate, which means the opposite sign in the middle. So if this one had a plus here, I would be doing minus 7 minus root x, top and bottom. But it has a minus, so I do 7 plus root x, top and bottom. Okay, let's bring everything down. The 1/11th is still here. The limit is still here. This is what will get rid of the root for us, the conjugate. And in fact, I should probably go a little further. Okay, so now let's multiply this up. So I'll put parentheses here. The top, the 49. Um, oh, you know what? Actually, yeah, here's the trick. Just for a moment, leave the 49 minus x and the 7 plus root x. On the bottom, though, I am going to go ahead and FOIL those guys. How do I know this? Just because of experience. So I'm going to multiply out on the bottom. 7 times 7 is 49 plus 7 root x. And now it's right. This guy went to both. He's done. Now it's this guy's turn. He'll go to both. That'll be minus 7 root x. and minus root x times plus root x is minus root x squared. Did you track with all that? Right? I multiplied the two parentheses on the bottom, first to both, second to both, at those four terms. Now, do you see the genius of this method? See how these roots cancel? See why we use the opposite sign in the middle? Because now we've got one positive and one negative, and the roots vanish. Okay. And by the way, yeah, let me add to our note. Only multiply the opposites. Right? You notice how I didn't multiply out the top. I only multiplied the bottom. Okay. So no, that's just kind of convenient. Could you multiply the top out? Yeah, it's not illegal or anything. You know, it's like saying I'm going to leave this 2 times 3 over 7 instead of making it 6 over 7. It's the same either way. I'm just telling you it's more convenient to leave it 2 times 3 for now. Leave leave this and this leave as they are for now. Don't FOIL them out. Don't multiply them out because something really nice is about to happen. Could you multiply them out? Yeah, it's not illegal or anything, but it's going to be way easier to only multiply the bottom here, the parts that are opposites. See, these guys are opposites, 1 plus 1 minus. Multiply them out, and then look at the nice thing that's going to happen. Super nice. Um, First off, what is the root of x squared? That's just x, huh? So on the bottom, we now have 49 minus x. What do we have on the top? Ah, 49 minus x. You starting to see it? Do you see why? Because now this will cancel that. Now you might be saying, wait a minute, Mr. Aaron, you said don't cancel added subtracted things. Well, you can take the whole term. That's fine. You just can't break up two things that are added and cancel just one of them. I always think it's like Costco. It's like shopping at Costco. Where you buy things in bulk, you buy one milk, it's plastic to another one. That's kind of what pluses and minuses are like in algebra, or now we're in calculus. We're doing advanced algebra basically. That is, it glues together. So these guys are glued, these guys are glued. It's okay. You can buy the whole glue package, but you can't buy just one of them, right? When you go to Costco, you can't buy one milk. You can't take your scissors to Costco and just break the bond. Say, I just want one, I just want the 49s. No, you got to buy the whole package. So it's fine. You can cancel added, subtracted items as long as you cancel the whole item. So that works. And so what does that leave us with now? Let's come down to here. Now we're left with 1 over 11, limit x to 49 of 7 plus root. There's nothing on the bottom. You just put a 1 down there if you want. There's really nothing. In fact, we don't even need the denominator anymore. Let's just make it 7 plus root x. Okay. And now we can plug in 49. So the 1/11th is still there. 7 plus root 49. 111 times 7 plus 7 is 111 times 14. Now, where's that 14 go? Well, it's 14 over 1, so it goes to the top. 14 over 11 is the answer to this problem. 14 over 11 is what they got up here. Yep. 14 over 11. Awesome. Yeah, there we go. That's how we do this. Let me recap for you real quick. So you from the beginning, you notice that these both have 11 in common. So you factor out the 11 and then just pull that to the front because it doesn't have any x's. It doesn't need to be after the x plug-in. It doesn't going to have an x plug-in. Just put it in the front so it's out of the way. And then you go, I got a root, added and subtracted. So when you have a root added or subtracted, you multiply the top and the bottom by the conjugate, which means opposite sign in the middle. So I just take that 7 minus root x and I multiply top and bottom by 7 plus root x. Only multiply out the opposites, though. It's just easier that way. Just multiply these guys out. Leave the top as it is. Multiply out the bottom, cancel, x root of x squared is x. See how it got rid of all the roots? And then these canceled. And then the problem became a piece of cake. Then we can plug in the 49, 14 over 11. And so there we go.